We know humans learn from their past experiences and machines follow their instructions given by humans. But what if humans can turn the machine to learn from the past data and to do what humans can act much faster? Well, that's called machine learning, but it's a lot more than just learning. It's also about understanding and reasoning. So today we will learn about the basics of machine learning. So that's Ajay. He loves listening to old songs. He either likes them or dislikes them. Ajay decides this on the basis of song's tempo, genre, intensity, and the gender of voice. For simplicity, let's just use tempo and intensity for now. So here, tempo is on the x-axis, ranging from relaxed to fast, whereas intensity is on the y-axis, ranging from light to soaring. We see that Ajay likes the song with fast tempo and soaring intensity, while he dislikes a song with relaxed tempo and light intensity. So now we know Ajay's choice. Let's see. Ajay listened to a new song. Let's name it Song A. Song A has fast tempo and a soaring intensity, so it lies somewhere here looking at the data. Can you guess where the ball will like the song or not? Correct. We were able to classify the unknown song very easily, right? Let's say now Ajay listens to a new song. Let's label it as song B. So song B lies somewhere here with medium tempo and medium intensity, neither relaxed nor fast, neither light nor soaring. Now can you guess where the Ajay likes it or not? Not able to guess with this, Ajay will like it or dislike it. Other choice is unclear. Correct. We could easily classify song A, but when the choice become complicated as in the case of song B. Yes, and that's where machine learning comes in. Let's see how in the same example for song B. If we draw a circle around the song B, we see that there are 4 words for like whereas 1 would for dislike. If we go for the majority words, we can say that Ajay will definitely like the song. That's all. This was a basic machine learning algorithm. So this is just a small example in one of the many machine learning algorithms. Quite easy, right? Believe me, it is. But what happens when the choices become complicated? As in the case of song B, that's when machine learning comes in. It learns the data, builds the prediction model, and when the new data point comes in, it can easily project for it. More the data, better the model, higher will be accuracy. There are many ways in which the machine learns. It could be either supervised based learning, unsupervised based learning, or reinforcement learning. Let's first quickly understand supervised learning. Suppose your friend gives you 1 million coin of 3 different currencies. Say 1 rupee, 1 euro and 1 dirham. Each coin has different weights. For example, a coin of 1 rupees weighs 3 grams. 1 euro weighs 7 grams, dirham weighs 4 grams. When you feed this data to the machine learning model, it learns which feature is associated with which slip. For example, it will learn that if a coin is of 3 grams, it will be a 1 rupee coin. Let's give a new coin to the machine. On the basis of weight of the new coin, your model will predict the currency. Hence, supervised learning uses label data to train the model. Here the machine knew the features of the object and also the labels associated with those features. On this note, let's move to unsupervised learning and see the difference. Suppose you have cricket data set of various players with their respective scores and wickets taken. When you feed this data set to the machine identifies the pattern of the player performance. So it plops this data with the respective wickets on the x-axis while runs on the y-axis. While looking at the data, you will clearly see that there are 2 clusters. The one cluster are the players who scored high runs and took less wickets, while the other clusters is of the players who scored less runs but took many wickets. So here we interrupt these 2 clusters as batsmen and bowlers. The important points to note here is that there were no labels of batsmen and bowlers. Hence, the learning with unlabeled data is unsupervised learning. So we saw a supervised learning where the data was labeled, and the unsupervised learning where the data was unlabeled. And then there's reinforcement learning, which is a reward based learning, or we can say that it works on the principle of feedback. Here, let's say you provide the system with an image of a dog and ask it to identify it. The system identifies it as a cat. So you give a negative feedback to the machine saying that it's a dog, not a cat. The machine will learn from the feedback, and finally, if it comes across any other image of a dog, it will be able to classify it correctly. That is reinforcement learning. To generalize machine learning model, let's see a flow chart. Input is given to a machine learning model, which then gives the output according to algorithm applied. If it's right, we take the output as a final result. Else we provide feedback to the trained model and ask it to predict until it learns. I hope you have understood supervised and unsupervised learning. So let's have a quick quiz. You have to determine whether the given scenario use the supervised or unsupervised learning. Simple, right? Scenario 1. So now you want Facebook recognizes your friend in a picture from an album of tagged photographs. Scenario 2. Netflix recommends new movies based on someone's past movie choices. Scenario 3. Analyzing bank data for suspicious transaction of flagging fraud transaction. Think wisely and comment below your answer. Moving on. Don't you sometimes wonder how is machine learning possible in today's era? Well, that's because today we have humongous data available. Everybody is online, either making a transaction or just surfing the internet. And that's generating the huge amount of data every minute. And that's data, my friend, is the key to analysis. Also, the memory handling capabilities of computers have largely increased, which helps them to process such a huge amount of data and hand without any delay. And yes, computer now have great compulsion power, so there are a lot of applications of machine learning out there. To name a few, machine learning is used in healthcare where diagnostics are predicted for doctors' review. The sentiments analysis that the tech giants are doing on social media is another interesting application of machine learning. Fraud detection in the finance sector, and also to predict customer churn in the e-commerce sector. While booking the cab, you must have encountered surge pricing often where it says the fare of your trip has been updated. Continue booking. Yes, please. I'm getting late for the office. Well, that's an interesting machine learning model which is used by global taxi giant Uber and others, where they have differentially pricing in real time based on the demand of the numbers of cars available, bad weather, rush hours, etc. So they use the surge pricing model to ensure that those who need a cab can get one. Also, it uses predictive modeling to predict where the demand will be high with the goal that drivers can take care of the demand and surge pricing can be minimized. Great. Hey Siri, can you remind me to book a cab at 6 p.m. today? Siri, okay, I'll remind you. Thanks. Comment below some interesting everyday examples around you where machines are learning and doing amazing jobs. So that's all for machine learning basics today.